process. So presented by Dr.P.Ponesakki Raja. So PSN College of Engineering and Technology. So advanced manufacturing process. It is one of the very important field in mechanical. So modern manufacturing process is defined as a group of process that remove excess material by various techniques involving mechanical, thermal and electrical or chemical energy or combination of these energies, but do not use a sharp cutting tools as it is need to be used for traditional manufacturing process. External, so extremely hard and brittle material are difficult to machine by traditional machining process such as turning, drilling, shaping and milling. Modern manufacturing process, also called non-traditional or advanced manufacturing process, are employed where traditional machining process are not feasible, satisfactory or economical due to special reasons as outlined below. So very hard materials difficult to clamp for traditional machining. When the workpiece is too flexible or slender, when the shape of the part is too complex. So several types of non-traditional machining process have been developed to meet extra required machining conditions. When these processes are employed so properly, they offer many advantages over non-traditional machining process. So definitions: the machining process is called non-traditional if it is material removal mechanism is basically different than those in the traditional process. For example, a different form of energy like tool which is in physical contact with the workpiece is applied to remove the excess material from the work surface or to separate the workpiece into smaller parts. So machining process, there are two types of machining processes there. First one is traditional machining and non-traditional machining process. So first one we have discussed about the traditional machining process. It is a cutting process. So circular shape and various shapes is there. So circular shape means turning, boring, drilling. So mostly three types of used in circular shape. Then various shapes is milling, planing, shaping, broaching, then filing, then gear forming, gear grinding. It is the various shapes for cutting process. So non-traditional machining, so chemical machining process, then electrochemical machining process, then electrical discharge machining, then laser beam machining process, then abrasive jet machining process, then water jet machining process, and plasma beam machining and ultrasonic machining process. These all the processes of non-traditional machining process. Then comparison with traditional process. So non-traditional process is mostly three bases there. First one is mechanical, then thermal, then chemical and electrochemical process. So mechanical process means you have to use it with ultrasonic machining, then water jet machining process, then abrasive water jet machining process, then jet machining process. Then thermal energy you have to use it in electrical discharge machining and electron beam machining, then laser beam machining, then ion beam machining, then plasma beam machining process. These processes also used in thermal process. Then chemical and electrochemical process you have to use it in three types: chemical machining process, then photochemical machining process, then electrochemical process. classification of the use ultrasonic testing machines is used by electron beams have to be used. An ultrasonic machining process is a non-traditional machining process. It is one of the UCM is grouped under the mechanical group. So ultrasonic machining, a tool of desired shape, is vibrates at an ultrasonic frequency. So frequency level is 19 to 25 kilohertz with an amplitude of around 15 to 50 micrometer. So over the workpiece, generally the tool is pressed down with a feed force. Between the tool and workpiece, the machining zone is coated with hard abrasive particles, generally in the form of a water-based slurry. As the tool vibrates over the workpiece, the abrasive particles act as the indenters and indent both the work material and the tool. The abrasive particle are as the indent, the work material would remove the same, particularly if the work materials is brittle due to crack indentations. So propagation and brittle fracture of the material. Hence, UCM is mainly used for machining brittle materials, which are poor conductors of electricity and thus not be processed by electrochemical and electro discharge machinings. The process parameter on their effect is during discussion and analyze the presented in the previous sections. The process parameters which ultrasonic machining process have been identified and the same and listed below along the materials. So parameter is amplitude of vibrations, so 15 to 50 micrometer. Then frequency of vibrations 19 to 25 kilohertz. Then feed force related to tool dimensions. Then feed pressure. Then abrasive size 15 micrometer to 150 micrometer. So then abrasive material AL203. So that is the parameter of the abrasive materials. Then next machining process. The basic mechanical structure of an UCM is very similar to an drill press. However, it has additional features to carry out UCM of brittle work material. The workpiece is mounted on a vise, which can be located at the desired positions under the tool using a 2-axis table. So the table can further be lowered or raised a accompanied work of different thicknesses. So the typical elements of the UCM. So slurry delivery and return systems. Feed mechanism to provide a downward feed force on the tool during machining. Then the transducer, which is greater than ultrasonic vibrations. The horn or concentrator with a mechanically amplifies the vibrations to the required amplitude of 15 to 50 micrometer and accompanied the tool at the ultrasonic vibrations are produced by the transducer. The transducer is driven by suitable signal generator followed by power amplifier. The transducer for UCM works on the following principles. So first one, piezoelectric effect, then magnetic electrode. Next one, the electrostructive. Then the application is used for machining hard and brittle material, alloys, semiconductors, etc. Then used for machining round, square, irregular shaped holes are used in UCM. Next, machining, wire drawing, punching or small blanking dies have to manufacture in this process. Next, electric discharge machinings. So electrical discharge machining is the process of metal removal from the work surface due to an erosion of metal caused by electric spark discharge between the two electrodes stored. One is cathode and another one is anode. So then the working principle is it consists of an electric power supply, the dielectric medium, the tool, workpiece and servo control. The workpiece is connected to the positive terminal and the tool is connected to a negative terminal of the DC power supply. And air gap of 0.005 to 0.05 mm is maintained between the tool and the workpiece. The dielectric fluid, which is non-conductor of electricity, is forced under pressure through the gap. When a DC power is supplied, the fluid in the gap gets ionized and produces a spark between the tool and workpiece. The temperature about is 1000 degree Celsius when melts the metal in a small area of the workpiece and tool. The DC supply generates pulse between 40 to 3000 volt and the frequency of spark at the rate of 10,000 spark per second can be achieved. The electric and magnetic field on heated metal has a compressive force which remove the metal from the work surface. The dielectric fluid act as a coolant, carry the coolant metal from the work surface. The dielectric fluid acts as a coolant. It is one of the coolant purpose that we use in the dielectric fluid. The servo mechanism is used to feed a tool continuous to maintain a constant gap between two electrodes. The accuracy of about 0.005 mm can be achieved in this process. Then an electric discharge machine consists of a DC bulb generator, then voltmeter, ammeter, tool, dielectric fluid, pump, filter, servo control feed, etc. There is also you have to use in the electric discharge machining components. Then DC pulse generator. So this is a power source of the machining operation. DC power is supplied. Then voltmeter. The voltmeter, the voltage here in this device is same for use. Then ammeter. If ammeter is not connected, we need not see or check current is following or not. Then tool. The tool is connected to negative source of power. The workpiece is connected to positive source from the filter. A fluid come to the tool for the operations. When power supply increase between tools workpiece, the spark generates and then machining starts. The next one, dielectric fluid. It has a property like insulation, and we know what insulation means. Insulation means no current flow from one to another. The dielectric fluid will be ionized in the form of iron, which will help between the tool and workpiece. Again, when power supply stop, the fluid come to its initial positions. Then next one, pump. The pump is connected there for sending the fluid to the filter. This work likes following the fluid from one source to another one. Then filter, as the name is, used to filter the different particle lights. In this device, in 3 dust particles present, the filter will remove the particle and then it will send to the tool for the operations. Then servo controlled feed. The constant feed will be supplied by the servo for the operations. Then the various parameters for EDM process. So process parameter and performance measures. So first one we have to see the process parameters for electrical and non-electricals. So electrical, for example, pulse and time, pulse of time, spark gap, discharge current, gap voltage, etc. So non-electrical is dielectric fluid, then electrode materials, then electrode shape, electrode rotations. And performance wise, the material removal rate, then electrode tool wear rate, then surface roughness, dimensional accuracy, and total machining times. That all the parameters for the EDM process. The EDM process parameter which derive these processes are divided into two types, namely electrical and non-electrical parameters. The major electrical parameters are discharge volt, peak current, pulse duration, and intervals. So electrode gap and pulse beam from important non-electrical parameters include fluidizing of the dielectric fluid. So workpiece rotations and electrode rotations, etc. The parameters are discussed below. The discharge or machining voltage is the very voltage across the spark gap during machining. The discharge voltage directly influences the regulations of the size, spark gap, and overcut. Normally, electrode and workpiece material of high electrical conductivity use slow voltage. In connect, high voltage is considered with material of low. So conductivity, this parameter have a different effect on the material removal rate. So and tool wear rate, then machining accuracy, and increase in current, etc. These characteristics of the parameter, current and its response open the door for electrodes of high wear resistance that can be used in high current conditions. The pulse on time is the time during which the discharge is applied, the amount of energy generated during pulse. So accordingly, increasing the discharge energy by applying larger pulse on time also increase the MRR. The pulse of time is the time during which there is no discharge during this time. Then the polarity and EDM depends on many factors including electrode and workpiece materials, current, density and pulse length. Either the electrode or the workpiece has a positive charge polarity and the other has a negative charge polarity. Negative electrode polarity